I'm extremely excited about the Target Wheel.
Oh, I'm very excited about the Target. I've been waiting for this moment for a long time.
This was very special.
The installation of the Target and the Moderator is one of the key milestones for the entire ESS project.
The Target Wheel is where worlds collide. It's where the three big parts of the machine come together. The accelerator, the target, and instruments. We're all focused around this one point.
The installation of the Target Wheel and the Moderator is a big milestone for us to get closer to the ultimate goal of being on target.
The ESS is a huge jigsaw puzzle. When you look at the target systems, there really is only one target and only one moderator. And they are absolutely essential for us to do our job, which is to be a neutron factory.
The Target sub-project is put together as a collaboration between the central team here in Lund and in-kind partners out in Europe. We have been working with this project since at least 10 years, with a very intense development phase to start, and then after that a very challenging construction phase and a production phase. The Target Wheel was delivered to ESS in March of 2022, and the Moderator Reflector plug came to site in August of the same year. And since then we have done extensive testing of both components to make sure that they are actually fit for purpose and that they will work when integrated into the Target monolith. The testing of the components has been done in a separate test stand. We call it the mock-up and test stand, which has been holding the Target Wheel and the Moderator for mechanical integration of those components, but we have also used it to make extensive testing. We have made a 1,000-hour testing of the Target Wheel operation.
Today we have installed the Target Wheel in its final position. We have worked a lot to make this happen, a long time, and we have solved many issues during the installation time.
It was a very special milestone to put that into the pedestal. Long planned, and everything went very smoothly due to the fantastic rigging team that handled the crane.
We call it the Target Wheel because it is the target for the proton accelerator, but it's in fact also the neutron source. It's the origin of the neutrons that will be later used by the instruments.
In the target area, we have delivered several key components such as the monolith vessel, the proton beam window, or the tuning beam dam. However, the most challenging component is the target system. This component is the heart of ESS facility, in which spallation reactions take place.
So, if you want to imagine spallation in real life, take a sledgehammer, swing it down really hard onto a piece of concrete, and see the pieces fly off. That's really spallation.
The protons from the accelerator hit a series of tungsten bricks producing the neutrons. The amount of heat is so intense that we need to assemble the tungsten bricks in a 2.6 meter wheel and spin it to distribute the heat. To keep it cool, almost 3 kilograms per second of helium flow inside the wheel.
We want to be at the end of the day a 5 megawatt source. So if you go up in power, you have to find a way to get rid of the heat you're putting into the target. And that means if you're coming to a megawatt class facility, like also the JPOC or SNS are, you need to find ways to actually get out the heat. So in order not to put too much heat into a certain sector, we actually ended up building actually 36 targets. Because yes, it looks like one big target, but if you look inside, it's actually 36 little targets, equal to basically what you would have at the Rutherford National Lab with the ISIS facility there. So it's a lot of little targets, and by rotating them, you're giving the targets enough time to actually cool down, so by the next time they get hit by the hammer, they have cooled down enough that they don't basically overheat.
The collaboration is really good. We have a very nice and tight collaboration.
The collaboration between ESS Bilbao and ESS Central Team has been excellent since the beginning of the project. We feel as members of the ESS team, even if we are far away from London.
So the neutrons that actually come out of the target wouldn't be actually very useful for science. They're far too energetic. So what we do is we cool them down.
The protons are really smashing to the target. It's really a violent process. What happens is that the nuclei of the tungsten, they will release neutrons. And these neutrons have a lot of energy. So the moderator is the real source of neutrons. It's really difficult to keep this guy cool. It's almost like having an ice cream in a sauna, and you have to keep it cool.
It takes them and slows them down to the right speed that we can actually use them for the instruments. Okay, slow in terms for the neutrons, things I think are slow. So we are still talking about 2 kilometers per second.
This is what we call the low-dimensional moderator. It's only 3 centimeters tall compared to regular moderators, which are about 3 or 4 times taller. It doubles the performance of ESS. Is what we call the low-dimensional moderator. We pioneered here at ESS, and is now the baseline for the design of all moderators in the new neutron sources or in the neutron sources under upgrade.
The Research Center Jülich is a big research organization which contains of several different independent institutions. The institute for which I'm working, the ZEA1, is specialized to develop and manufacture scientific instruments, processes and devices which are needed for research and not available on the market. ESS is a perfect example for it. So there are many prototypes which never have been built before, like the moderator system which we have delivered. We were already involved in the so-called design update phase. So I remember when I visited ESS, I saw the green field.
Today we have successfully installed also the moderator, the second very major component in the monolith area.
Now we are standing here after 9 years, and it's a very, very special moment. So what we have done, we have finally brought the moderator reflector plug, also twister, into the monolith to bring this heart of ESS, or one heart of the butterfly moderator, into position where all the instruments will look at the cold moderator and the water moderator cross. And now it's done, and I'm very happy that we managed to do this.
We work very close together, so we do not distinguish between ESS and Jülich. So we are building the European spallation neutron source. It is located in Lund, but I count that also as our spallation source, and that is also how we do the project. So we are very transparent to each other and work on the same level, and that's really nice. So I'm really happy about this constellation. We choose the right way to fix the problems together, and now we can celebrate the final installation, for sure.
There are so many things that we cannot predict now, but we will be running for 40 years. This is what I really find amazing as a scientist, the fact that we are building the future. And sometimes as a scientist, what I really think, and I like it, is the idea is that what I'm doing now will be used maybe by some people that could be my grandchildren. And this is, for me, the most stimulating part of my work.